We're going to look at catalysts in aerospace, and particularly aircraft and spacecraft uses. And remember, their utility comes with the properties of catalysts. They're used to speed up reactions and allow the reaction to take place at a lower temperature. This happens because you're lowering the activation energy of the reaction. So you're looking here at an energy level diagram, and the bump is the amount of the highest energy that has to be overcome for the reaction to take place. So the activation energy, and you are lowering that with the dotted line with the presence of a catalyst. So they're going to make aircraft and rocket fuels react faster. Examples are hydrazine and using a metal iridium catalyst. So these, the hydrazine would be fuels in space shuttles, messenger spacecraft, F-16 and U-2. And this is the hydrazine molecule N2H4, covalently bonded. It's corrosive, toxic, very flammable, and is used with care. It's used in H70 fuel, which is 70% hydrazine and 30% water by mass. Used in other aircraft as well, and way back, the launch rocket for the Corona surveillance satellites. So we've got decomposition of hydrazine with two reactions, one forming ammonia initially, and then the ammonia decomposing. That second reaction is the slow reaction, so the rate determining stage. You can look at it overall as that reaction, and we're putting the iridium catalyst in the equation here. The reaction is slightly different at a higher temperature, again with a catalyst. And the iridium is a heterogeneous catalyst. In particular here, the iridium is a metal, a solid, and the fuel is a liquid. At high temperatures it may be gaseous. So you've got two different phases. That's your heterogeneous catalyst. And here, just to look at the Ranger Mariner spacecraft engine with the catalyst in present, and more information than you need just to look at it as a system. The U-2 spy planes that flew at very high altitude, again with hydrazine fuel in an emergency power unit, and using the iridium catalyst. Here's a U-2 pilot. Because of the high altitudes, over 20,000 meters, the pilots were wearing spacesuits. And you can look at different pilots and different missions as well. And this is the ER2 research aircraft based on the U-2, again using the iridium catalyst. And an auxiliary power unit, and more information, and the emergency power unit in space shuttles, and it's circled here. The Corona surveillance satellite with the Thor Agena rocket, again using hydrazine fuel, and other information about rockets that are using the fuel. So for Mariner C, you've got the amount of the catalyst, which is much higher in space-based proportions of iridium than when it's used on Earth. And there are other catalysts that can be used, iron, nickel, and cobalt. And here an alumina, which is used on an alumina, which is aluminum oxide carrier to facilitate the decomposition of the hydrazine. The hydrazine's very flammable and explosive, but it's not shock sensitive. More about the F-16, and you can pause to see more. And here are images of the F-16, and then working on the system with the fuel filters that are inside there. And again, the equations here, and showing the emergency power unit, and looking at some other space vehicles that use the catalysts too. We have manganese dioxide and the Messerschmitt comet, and there's a comet at the Air and Space Museum Stephen F. Udvar-Hazy Center. And here's the Thor Regina rocket. Again, you can see artifacts relating to this at the National Air and Space Museum Stephen F. Udvar-Hazy Center. And on the top left, you've got the capsule that returned the discs, and the airplane that captured the container that was there. And if we're talking about catalysts at the movies, if you've seen the movie The Martian, you may have missed the significance here, where he at one stage says, if I run this hydrazine over an iridium catalyst. And in the Messenger probe visiting Mercury, and again hydrazine with an iridium catalyst. And you may research a few more uses as well.